This 2025 paper 2 question 10, we're given a standard distribution here and told to use the empirical rule. So this bit in the middle, that's just the mean always. That's how the standard distribution works. So we just have 400 because that's the mean, we're told that. And then over to the right, this is going to be one standard deviation up. So it'll be 460. How do we know it's one standard deviation? Because it's 68% here in the middle. And then going the other way, that'll be 340. And then you can see to the right, we add another 60. So presumably that's 2 standard deviations. So then 2 standard deviations this way will give us 280. Then we're told to use the normal distribution to work out the proportion that would score above 420. So first of all, we need to figure out how many standard deviations is 420. And we do that by computing the z-score. So here's the formula for the z-score. So x is our value, so it's 420, minus mu, which is the mean, which is 400, divided by the standard deviation, which is 60. So that means that this is, so that'll give you 20 on the top, 20 over 60, that's a third, or about 0.33, roughly. 33 repeating technically. 2 decimal places, so 33 is probably fine. And this makes sense, because this is kind of like a third of a standard deviation, because 20 is what our thing is, 420, it's 20 above the mean, and 60 is a standard deviation, so this is a third of a standard deviation above the mean. So then, if we go to the formula and tables booklet, you can see our value z here. So if we go to 0.33, we see the value 0.6293. So the probability that our score, which we'll just call z, is less than 0.33, so 0.33 standard deviations. The probability that it's less than that, given by this diagram, will be, again, 0.33. I'll put a little circle around it here. 0.6293. 0.6293. That's how many will be to the left of it, but we want to see the proportion that'll be above 420. So this is how many will be below it. So to get the number above it, we'll do 1 minus 0.6293. And when you put that into your calculator, you'll get 0.3707, and this is 2 decimal places, so we'll say 0.37 is the proportion. Then in part B, we're told to do a 95% confidence interval for the population score, mean score of country X. So we have the mean score, we have the deviation, and we have the size of the sample. So first of all, we need to figure out what the error is. So here's the error. It's a formula in the formula and tables booklet. So the error, which I'll just call E, will be equal to the standard deviation, which is for x, it's 66.2, divided by the square root of the size, which is 2161, and then we have to multiply that by 1.96 as well, because for 95% confidence, the reason it's 1.96, by the way, is because if you go to the formula and tables booklet and you look at 1.96 standard deviations, you see it's 97.5%, so that gives 2.5% to the right of it, and then 2.5% on each side is 5%, so that's where our 95% confidence interval comes from. That's the reason why it's 1.96. So we multiply this number by 1.96, and that gives us the error. Remember, it's at 2 decimal places up above, but we'll do that for now. So we'll give this as 2.79, and then we'll give our final answer to 1 decimal place. We'll just keep it as 2.79 for accuracy here. So this is kind of how far we're allowed to go either side of what we observed. So for the sample, we know that our actual value of the mean, at 95% confidence, it will be between 2 numbers. The bottom number will be what we observed, which is x bar minus whatever our error is, and the top number will be x bar plus what our error is. And at 95% confidence, we are sure that the actual thing is in between these 2 numbers. So the mean that we observed was 387. So on the left side, we'll have 387 minus 2.79, and the mean, and then on the right side, we'll have 387 plus 2.79, and then we can just add those up, and we'll get 384.2 less than or equal to mu, less than or equal to 389.8, and those are rounded to 1 decimal place. Then in part C, part 1, we're told to find the test statistic, or the z-score of the sample mean for country Y. So for country Y, we have this information, and because we have a sample mean, we're going to use this formula for hypothesis testing. It's the z-score for a sample. So we have that the z-score will be equal to x bar. So that's for Y. So that'll be 403 minus the actual mean, which we're told is 400 for the worldwide mean, which is what we're comparing it to, divided by, and then what we have is the standard deviation, which is 70.6, and then divided by the square root of the sample size, which in our case is 2724. So over the square root of 2724, and then we can just put that into your calculator, and you get approximately, well, you'll get 2.217 788 dot dot dot, and then just 2 decimal places, we'll have 2.22 as our answer. Then we're told to work out the p-value. So that's just the probability that whatever we observed wouldn't happen, kind of like that. So 2.22 standard deviations above is what it is. That's our z-score. So we find 2.22. So we go to 2.0, and then we have 2.22 here. Sorry, 2.22 is here. We get 0.9. Sorry, it's 2.22. Should be, apologies. That's 2.2, so 2.22 is over here, 0.9868. So basically, that's the probability that it'll be less than that if you look up to the graph. That's probably it's going to be below that. We want to see what's the probability that we would observe something higher than this kind of crazy statistic, and that's going to be basically 1 minus that number. So we'll have 1 minus 0.9868, and when you put that into your calculator, you'll get 0.0132. And then that's only one side of the thingamajig of the distribution. So we multiply that by 2. So we get 0.0132, multiply that by 2, and we get 0.0264. And that's our p-value there. And the way that we interpret this, basically, the way that I like to think about it, is this means that the odds of getting a number this extreme, kind of like this sample, what are the odds of getting this mean from the sample? Well, there's a 2.6% chance that we'd get this. And that's pretty rare. And at 5% confidence, that means we're looking for it to be bigger than 5%. So we want the probability to be bigger than 5%, where we could say, okay, maybe it could happen. But this is way smaller than 5%. So it's kind of like, okay, there's no way this could happen. So the conclusion that we can draw, the conclusion is that the mean score is different to the worldwide, which was 400. So again, it's really unlikely that this is just an outlier. There's only a 2.6% chance of that happening. It's one way you can interpret it. So that means that our conclusion we can draw at 5% significance is that it must be different. So for part D, we're asked how to take a stratified sample and why it's probably not useful. So I've just put it up on the screen here because there's kind of no, I suppose, how to do it. It's just kind of a fact, but I'll explain what it says here. So basically, it's kind of like having a strategy when you're taking out your sample. So with respect to having a pet at home, that means we want half of them to have a pet at home and half of them not to have a pet. And we do that completely randomly. It's important that you mention that, as you can see here. And the reason why that's probably not useful is because there's probably no connection between owning a pet and the score you get in a maths test. So here we're given some information. We're told to find the largest possible value of the expected value. So first of all, let's just calculate the expected value. So we know that when we add up all these probabilities, first of all, we will get 1. That's just a fact of how probability works. So 0.19 plus p plus 2or plus or will give us 1. We can do a bit of simplifying with the 0.19 to the other side. We get that p plus 3r will give us 0.81. That's a useful fact to know. And then let's just figure out what the expected value is actually going to be. So we just multiply the probabilities by their marks. So 0.19 times 0 plus p plus 2 times 2r plus 3r. Okay, so basically we can simplify that a little bit and we'll get p plus 7r pretty much. So what we notice is that p being big isn't as important as r being big, because p is not multiplied by anything, but r is multiplied by 7. So we can get r to be as big as possible, then we have a bigger number being multiplied by 7, and that's the best way we can do this. And I suppose a way that you can think about it in terms of the table is that the bigger that these r's are, the more people we have getting 2s and 3s, which is good. So we want to make p as small as possible so that we can make r as big as possible. And the smallest that p can be is to let p equal 0. And then we can actually solve this quite easily. So that means that 3r will be equal to 0.81, or in other words, r is equal to 0.27. So then the expected value will just be equal to 7 times 0.27, and you can just put that into your calculator, and you get 1.89 as the expected value. 1.89 marks if you want to be specific about it. And yep, that's it.